Comment 1456 basically points out that you mixed up similarity and congruence. So I'll just remind you what they are. Similarity is when two shapes are undistorted photocopy enlargements of the other. And you can tell if there's distortion going on because the angles change. If the angles don't change, you're on your way to something being congruent. In fact, in a triangle, you only need two pairs of angles to be the same. That's equal to that, that's equal to that, done. So that's similarity, when one is allowed to be larger than the other, but there's no distortion. Okay. Congruence is when they're similar, so no distortion, but where the enlargement factor is actually 1. So in that case, everything will be equal. That'll be equal to that, that'll be equal to that, that'll be equal to that. That will be equal to that, that will be equal to that, that will be equal to that. So congruence is a special case of similarity. They are established completely differently. There are 4 ways to prove congruence: RHS, SAS, AAS, and SSS. No other ways. And there's 3 ways to establish similarity of triangles. There's 2 angles, this being equal to that, or 2 sides in the same ratio, so doubling there and doubling there with the angle in between being equal, or alternatively, all 3 sides being in the same ratio. So if that was 8, that would be 16. Now, for other shapes, similarity can really only be established one way, which is all the angles match, and all the sides are in the same ratio. So timesing by 10 there, timesing by 10 there, timesing by 10 there. Sorry, this is a terrible diagram. Timesing by 10 there. So that's similarity for general shapes. And there's no general way to establish congruence of shapes, but similarity of shapes is something that you might get in your exam. Sorry, I mean general shapes, not triangles. Congruence and similarity of triangles is something that you should be extremely well practiced on.